James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth.
This is the first object that was spotted close to Earth from outside the solar system. It must be a piece of rock, just like all the asteroids and comets.
Sometimes the universe places mystery within our reach, unbidden. July 1st, 2025, a date that stands out for astronomers, witnessed the arrival of an object so swift and unusual, it set the global scientific community abuzz. This object, named 3I/ATLAS, wore the I for Interstellar, joining only 2 previously confirmed interstellar visitors observed within our solar system. Yet even amid these rare ranks, 3I/ATLAS immediately distinguished itself, both for its extraordinary speed and for the questions its passage provoked. At a blistering 245,000 kilometers per hour, it became the fastest known interstellar body to traverse our local space, easily outpacing the velocity of any similar object previously recorded. The initial images, gathered by powerful telescopes including Gemini South and Pan-STARRS, slowly resolved a cometary visitor of striking activity. A quickly developing tail, a brightening coma, and dynamics suggesting recent awakening as the object greeted our sun's warmth. Through careful observation and analysis, astronomers soon confirmed its nature as a comet. Its emissions of gas and dust, its shifting brightness, and the solar wind-driven formation of its tail all fit the classic patterns of an active, icy body from deep space. Yet even as scientists established the nature and trajectory of this visitor, speculation grew at the margins. What exactly could explain such enormous speed? Was it the consequence of ejection from some distant solar system's violent past? Or did it hint at cosmic processes we do not yet fully understand? And, perhaps most important, was 3I/ATLAS traveling alone? Or did it hint at a larger story unfolding beyond the reach of our current instruments? The fastest visitor in history. To grasp the significance of 3I/ATLAS, one must first appreciate just how anomalous its speed is. Roughly 245,000 kilometers per hour, a record among known natural objects entering our solar system. For comparison, this is over 60 times faster than a rifle bullet and sufficient to traverse the distance from the Earth to the Moon in under 2 hours. This dramatic speed suggests a powerful origin, likely an energetic ejection from another star system flung into interstellar space by gravitational slingshot or ancient collision countless millions of years ago. Prior to 3I/ATLAS, only 2 interstellar objects had been confirmed passing through our solar system in modern times. The first, 1I/Oumuamua, was detected in 2017 and quickly made headlines due to its bizarre elongated shape, puzzling spin, and unexpected acceleration as it departed. The second, 2I/Borisov in 2019, conformed more closely to classic comet expectations, a small icy body, its outgassing easily visible as it approached and retreated from the sun. Both objects, however, were slower than 3I/ATLAS, and their fleeting appearances underscored the rarity of these cosmic travelers. Why so few? Despite the apparent vastness and activity of the galaxy, the observable interstellar visitors remain rare and often escape detection unless they approach relatively close and shine brightly enough under the sun. It is possible that our observational capacities favor the discovery of the brightest and fastest examples, those objects crossing through our region in dramatic, short-lived arcs. The swiftness of 3I/ATLAS only reinforced how little time we have to study such visitors before they vanish back into the darkness, never to return. A mysterious comet, signs of distant origins. How can we be sure that 3I/ATLAS is truly an interstellar object? The key lies in its trajectory and velocity. Native solar system objects are governed by the pull of our sun, tracing out closed elliptical paths. In contrast, 3I/ATLAS was observed following a hyperbolic path, an open-ended curve on a one-way journey from points unknown to destinations beyond the sun's reach. Calculations of its hyperbolic excess velocity confirmed that, Even when accounting for gravitational influences, it was not bound to the Sun. If undisturbed, it would never return. Spectroscopic studies too supported its distant origins. Analysis of its emissions detected the presence of volatile materials with ratios hinting at formation conditions unlike those typical for local comets. Some findings suggested unusual patterns of carbon-bearing molecules and possibly heavier isotopes, a chemical signature implying it was shaped in an environment distinct from our Sun's formative region. Visual and instrumental observations only increased the object's intrigue. On August 27, 2025, Gemini South in Chile captured a clear image of its growing tail, another line of evidence confirming its status as an active comet warming up under solar radiation. The combination of its activity, hyperbolic course, and apparent chemical novelty painted the picture of a true interstellar outlier. Uncertainty and cautious speculation. With these remarkable findings came a wave of interest, not just from astronomers, but from the public and beyond. As happened with Oumuamua and other extraordinary discoveries, a tide of speculation accompanied the hard scientific facts. Among the claims circulating were reports that a classified government document hinted 3I/ATLAS might not be solitary in its journey. Rumors suggested the possible detection of a second dim object sharing its course, a companion traveling through interstellar space. These suggestions, if true, would have profound implications for understanding both interstellar dynamics and the origins of such wanderers. It is important, however, to scrutinize such claims with care. To date, the prevailing evidence in the scientific community firmly supports the classification of 3I/ATLAS as a natural comet, traveling alone. Claims of a companion are, at best, speculative and unsupported by any corroborated public data or peer-reviewed analysis. As with previous interstellar findings, agencies like NASA rely on natural explanations consistent with observational evidence unless and until extraordinary data demands otherwise. Past extravagant theories, such as suggestions regarding the artificial origin of Oumuamua, have been critically reviewed and dismissed in favor of more probable natural causes. Astronomers search the data. Nonetheless, the mere idea of a possible companion prompted astronomers to look more closely at every data set available. Groups pored over images from Gemini South and elsewhere, searching for anomalies in the comet's tail, coma or trajectory, unusual deflections, brightness variations, or traces of gravitational perturbation that might hint at another object nearby. Advances in image processing and analysis were brought to bear, stacking exposures, subtracting noise, and modeling dust plumes to test the companion hypothesis. Some teams detected subtle oddities, minor deviations in light curves, or transient asymmetries in the tail's orientation. Such features, however, can often result from the inherent complexity of comet outgassing or from limitations in data quality. The immense speed of 3I/ATLAS further complicated efforts, as even small errors in alignment or exposure could produce apparent but ultimately spurious features. Most astronomers concluded that, based on currently available public evidence, there is no clear indication of another physical object accompanying the comet. Why the idea of interstellar companions is so captivating can be traced to our broader ignorance about the processes that shape deep space. Theoretical models allow for the possibility that, under rare circumstances, multiple objects might be ejected together during planetary system disruptions or stellar encounters. But conclusive observational evidence for such interstellar groupings is lacking. For now, the paradigm remains. Interstellar comets, if they enter our solar system at all, do so as lone wanderers more often than not. The limits of knowledge and the value of caution. Across scientific history, each new visitor from beyond the Sun has forced astronomers to reconsider settled assumptions. Oumuamua challenged the notion of what a comet looks like. Borisov's chemistry hinted at unexplored reservoirs of cosmic material. 3I/ATLAS now tests our theories on the ejection and travel of bodies from alien star systems. Should robust evidence of a companion ever emerge, the implications would be sweeping. It could mean that such ejections are not always solitary events, with groups of objects sometimes flung into interstellar space together. Alternatively, the gravitational and magnetic highways threading through the Milky Way might concentrate debris into streams or clouds, making tandem arrivals more likely than previously thought. Yet, these remain hypotheses, not conclusions. Meanwhile, there is enormous scientific value in rigorous skepticism. Extraordinary claims require extraordinary evidence. Most anomalies dissolve under scrutiny as natural variations or artifacts of observation. Astronomers, for all the drama of discovery, maintain their focus on established methodologies, verifying outliers, modeling trajectories, and ruling out known sources of error before entertaining radical revisions of theory. Expanding the search, the role of new technology. Even as 3I/ATLAS fades from view, the lessons it brings inform the future of astronomical discovery. Improved technology, larger telescopes, faster detectors, dedicated sky surveys will make it possible to discover fainter and faster interstellar objects. Projects such as the upcoming Vera C. Rubin Observatory promise to revolutionize our ability to systematically track sudden arrivals, allowing scientists to accumulate a statistical sample and refine our understanding of how and why they appear. With each new detection, scientists will probe not only composition and trajectory, but seek signs of clustering, streams, or patterns that might redefine our understanding of galactic matter distribution. It is likely that many more interstellar comets pass through the outer reaches of our solar system every year, simply escaping notice because of their dimness or remoteness. As algorithms become ever more adept at teasing out subtle signatures from across the sky, we will learn whether objects like 3I/ATLAS are merely rare exceptions, or the leading edge of a vast and mostly invisible phenomenon. Interstellar Wanderers: What We Know and What We Don't. What 3I/ATLAS truly signifies is the narrowness of our current window onto the universe. Just 3 confirmed interstellar objects in less than a decade hints that such bodies may be more common than previously suspected, waiting in the shadows for discovery. Each new arrival compels a reconsideration of our place in the galaxy and the processes by which stars and their attendant debris redistribute matter across millions of years. It is still an open question whether clustering of interstellar objects occurs with any frequency. While the circumstances necessary to eject multiple gravitationally bound objects from a system exist in theory, especially in the chaotic environments of star-forming regions or planetary migrations, direct proof awaits further discovery and analysis. Until then, astronomers continue to refine their models and chase each faint glimmer from deep space with equal parts skepticism and awe. Fact and fiction, disentangling the record. The scientific community's response to rumors of a leaked CIA report on 3I/ATLAS must be understood in the broader context of how extraordinary astronomical discoveries are handled. Agencies such as NASA publicly dismiss ideas that outpace available data. The narrative arc from unknown visitor to confirmed interstellar comet is paved with precise measurements, collaborative analysis, and peer review. Sensational claims, however captivating, are evaluated on the strength of independent, reproducible evidence. As it stands, the balance of observable data weighs solidly in favor of 3I/ATLAS as a solitary comet from outside the solar system. Apparent anomalies are pursued through meticulous modeling and cross-comparison with the well-understood physics of cometary behavior, solar-wind interactions, and instrumental limitations. Should truly compelling evidence ever arise, whether for a companion object or another cause for surprise, it will be met with the full scrutiny of the scientific method. Until that time, the most productive approach is to push the boundaries of detection and understanding, rather than drawing premature conclusions from incomplete or ambiguous data. The broader implications: building the map of the unknown. The greatest value of 3I/ATLAS lies in what it teaches us about exploration itself. Interstellar objects, by their very nature, are messengers from realms unreachable by spacecraft or remote sensing. Each one carries the story of its origins. Chemistry, structure, and trajectory all provide clues to the processes at work in alien planetary systems, the violence of their past, and the rhythms of galactic migration. Each confirmed interstellar object reshapes our cosmic expectations. The galaxy is not static. It is alive with the movement of matter, scattered and recaptured in cycles spanning millions of years. By incrementally refining our ability to detect and study such visitors, we expand the map of the unknown. The slow accumulation of data will, in time, allow us to answer not only how common such objects are, but if patterns, clustering, stream-like behavior, or signs of ancient catastrophe are written in their distribution. What remains certain is this: even with only a handful of confirmed examples, interstellar comets have fundamentally shifted the field of planetary science and opened up new questions about the nature of the solar system's interactions with the galaxy at large. A measured sense of wonder. What endures beyond the details of discovery or the bounds of any single investigation is the sense of awe provoked by each interstellar arrival. 3I/ATLAS, with its record-setting speed and distinctive activity, embodies the principle that science advances not by jumping to the extraordinary, but by incrementally pushing outward the limits of the explainable. It is not disappointment that speculation about companions remains unproven, but rather a testament to the rigor with which such claims are examined. The value of skepticism is not to dampen curiosity, but to make the eventual recognition of true breakthroughs all the more robust. As 3I/ATLAS continues its trajectory out into the galaxy, past the reach of our instruments, it serves as a reminder that the universe is alive with movement and possibility. Each icy wanderer glimpsed crossing the sunlight is proof of our own minuscule place within a far grander story. Looking forward, what comes next for humanity's understanding of the cosmos will be shaped by better technology, collaborative observation, and an openness to rewriting old assumptions in light of new evidence. Objects like 3I/ATLAS reveal that the galaxy is not an empty void, but an intricate highway along which planets, debris, and perhaps far stranger things occasionally pass into our narrow field of view. For scientists and laypeople alike, the lesson is perennial. The process of discovery is ongoing, open-ended, always inviting wonder, but requiring patience. The existence of a companion object to 3I/ATLAS remains for now a possibility unsubstantiated by current evidence. But the meaning of its passage does not depend on secrets in shadowy reports. Rather, it is found in the data, in the methods, and in the shared pursuit of understanding that each encounter with the unknown kindles anew. As we look to the sky, tracking the receding comet through the dark, we honor the patient discipline of astronomy, a pursuit that blends curiosity, skepticism, and hope in equal measure. The next visitor, faster, fainter, perhaps less ambiguous, may be approaching even now, bearing answers to questions we have only just begun to articulate. Until then, we keep searching, certain only that there remain wonders enough among the stars for 1,000 generations yet to come.